We're going to build a homemade cooler that uses a small flame as its power source. Stay until the end of the video to see how we do it. Do not try to replicate what you will see in this video without the proper training or safety precautions. To make the condenser coil, we'll use a 1/4-inch copper tube, 1.2 meters long. We'll need this paint can to shape the coils. We'll make 3 elongated coils like this. And we'll cut off the excess tubing. This is how it should look. We'll continue building the evaporator. For this, we'll also use a 1/4-inch copper tube, 3.5 meters long. In this case, we'll use the same paint can, but we'll make the coil completely circular. This coil will be the part of the system responsible for generating cold. We'll bend the ends like this to connect them later. We're going to use this small piece of 3/8-inch copper tubing to make a check valve. This will be the charging valve for our cooling system. We'll remove the valve core so it doesn't burn when we solder it. We carefully unscrew it and remove it. Since this cooler uses a flame to operate, we must solder the joints by heating with MAPP gas and using copper and silver brazing filler rod. Once welded, we mark here. We drill with a small drill bit. And now we enlarge the hole with a 1/4-inch drill bit. We file down the burrs. Now we're going to weld this small 1/4-inch tube into the hole. The valve will be welded to this end of the evaporator coil. We cut this tube a little. With the drill and a countersink, we'll reshape the tube hole this way. This is a steel ball from a bearing. It measures 6 millimeters in diameter. It must sit perfectly on the tube hole. This valve will work as follows. It will help the gas to always flow in this direction. When the gas arrives from the evaporator, the pressure it generates will lift the ball and allow passage to the outlet tube. The gas cannot flow in the opposite direction because the ball will obstruct the passage to the evaporator. We weld here. And once welded, we check that the ball moves freely inside the check valve. With this piece of copper tubing, 22 millimeters in diameter and 100 millimeters long, we'll make the tank. We put these two caps on the ends. We need to make two holes. One here and the other here. We mark them and drill with a 1/4 inch drill bit. We remove the burrs from the holes. We have to empty any remaining shavings from the circuit. The tank is now ready to be soldered. We must insert the valve's outlet tube into this hole in the tank. We heat it with the torch, and we solder the cap and the valve tube. Now we place the condenser in position. And we solder it. Since the entire surface is quite burnt, we're going to polish it with very fine sandpaper. It looks very nice, doesn't it? Let me know in the comments if you like its appearance. Now we bend the condenser tube like this. And the evaporator tube. And we align both tubes. This piece of tubing, 12 centimeters long, has a hole 0.6 millimeters in diameter. We'll make the capillary tube with this very thin tubing. We'll use a pen to shape it into a spiral. And bend the ends like this. It should look like this. Now we're going to connect it to the ends of the condenser and evaporator. We'll flatten the ends slightly to secure the capillary tube. Since it's such a thin tube, we need to be especially careful when soldering it so it doesn't melt. We'll polish the solder joints again, and our refrigeration circuit is finished. We've prepared this wooden base to mount it on. We'll screw this wooden support in place with these two screws. We'll also attach this stainless steel plate here. We'll use these clamps to secure the pipes. We place the cooler in its position, and it fits perfectly. Now we replace the Schrader valve on the gas recharge valve. Finally, we'll use isobutane gas as the refrigerant. We'll charge it by pressing it against the filling valve. close the valve. This small candle is all we need to operate the system. Our refrigerator is now ready. It's very important that the tank is slightly tilted so that, as it heats up, the gas flows towards the condenser. This end is slightly higher. To test our cooler, we place and light the candle. As the gas heats up, it will generate more pressure within the system, which will push the ball down, preventing its passage. Therefore, the gas can only flow in this direction. It will pass through the condenser and upon reaching the capillary tube will undergo significant compression due to its narrowness. Upon reaching the evaporator, the gas will expand rapidly, causing intense cooling. The cold gas will then pass through the entire coil, and upon reaching the valve, it will push the ball upwards, allowing passage to the tank, where the cooling cycle will begin again. Today, we can see a similar system in refrigerators that run on butane or propane. In just 2 minutes, we can see frost forming in the circuit. It's real ice. Here you can see how it melts due to body heat. It generates an extreme cold of minus 17 degrees Celsius. And now for the final test. Will it cool a can of soda? We wait a few minutes while the cold takes effect. And our drink will be perfect for a hot day. When we blow out the candle, the flame goes out, and the system slowly defrosts. If you like this video, give it a like and comment where you would use this refrigerator. Thanks for watching the video to the end. Let us know if you've built your own and how you've used it to improve your life. See you in the next video.